Thank you all. Yeah, 15 years of experience. Yeah, I might look young, but I am not. Yeah, I'm kidding. All right, so let's start. The secret weapon. I was thinking yesterday what the secret weapon thought about was the second title of this talk would be. But Codemods, I'm pretty sure not many people use Codemods, and I think not many people know about Codemods. But just asking you, who knows Codemod? What is Codemod? So Valik knows. Okay. Who uses? Two people, right? Who uses Codemod or used Codemods? No one. Great. So I'm pretty sure you will learn something new today. So let's start. My name is Konstantin, and I'm software development consultant at Xibia. In my free time, I also organize conferences and meetups. Feel free to reach out. I will be happy to talk about anything, about JavaScript, about anything. So please reach out me in my network channels. So agenda of my talk today. So I will talk about Codemods, about concept of Codemod, about ES3 specification history, about AST. I will dive into JS code shift in action and some abstract topic, what's next. So what is a Codemod? Let's start simple, right? So how does the actual process of changing code looks like? We have a source code, we have a developer, he does some programming, and then we have modified code. This is basically the way we work, right? And if you want to make it a bit more automated way, like we can programmatically change code, now we're talking about Codemods. So Codemods is basically a transformation that applies to your code base programmatically. So it allows you to make a big number of transformations without like going through every file every time. Use cases, how Codemods can be used. So we can think of like code refactoring, standardization, dependency updates, framework migrations, automated API migrations. You can tell more because Codemods is just a tool, and you can think of any other ideas you can apply it to. And let's look at some real examples. For instance, React, right? They provide this React Codemod package, which allows you to run some updates within your code base. And for instance, they provide this Codemod called Update React Imports. So at some libraries or version libraries ago, they needed to use global import of React to compile your code from JSX. With some updates in Babel and React itself, it's no longer needed. So basically, they ask you to remove all import of React. But to help you with all this hassle, they basically provide Codemods that does this trick for you. Same for Angular. So they have also Codemods that migrates your code base from one version to other version. Of course, it doesn't migrate all code, but some helpers here. Or Next.js, right? So they have Next OG import, for instance. They have many Codemods, but this is one of the import, for instance, to update imports of some image response import. Or Storybook. Yeah, they had the Codemods, for instance, to migrate from old legacy API for stories to the new ones. So what is Codemod? You might ask, like, what is basically, is it just a programmatic way to update your code? Let's look at this example, right? So we have some source files called payment success TSX. We load this file in the source constant. Then we just use replace all here, just replacing old primary button with new button, for instance, guide primary. We also using this open tag here, and we have new source code. It's just a string, right? Then we saving this file to some source. Can we say this is Codemod or not? Technically, this is a Codemod, right? Because we have some script that updates our code, but it's not really elegant. We just use string replace. So there is a better way to modify our code. It's using AST. Who knows what is AST stands for? All right, I think half of people know. So AST is abstract syntax tree. Before we go deeper in abstract syntax tree, let's first think about ES3 spec history. So ES3 basically stands for ECMAScript tree specification. So ECMAScript tree specification is basically a specification or standard for abstract syntax tree for JavaScript. And why we need to go deeper in this history is just to understand why we can use now Codemods. Who was born before 90s? All right. Who was born after 90s? Okay, so like 40% was born after 90s. Great, yeah? So basically the people who born after 90s, you were already born with the internet, right? And other people not. So internet was born in 1990s in CERN. It's a European organization for nuclear research. And researcher Tim Berners-Lee, he created a plan to open source computer network to other scientists just to share information, some files, some researches. He also created a web browser to access these files, but it was not the browser we used to have now. It was something different. 1993. Internet was not popular at all because it was used only like for the scientists and research. And first kind of mainstream browser was released. His name was called Mosaic. Basically, this browser was not the first browser. It was already second or third attempt. There are other failed attempts of making a browser, but there were some United States organization with government behind who made some fundings. A guys came up with this Mosaic browser. It was used already some by other people, not only researchers, and it was basically developed by Mark Andersen and Eric Bina. And internet started growing. And Mark Andersen and James Clark actually saw a big commercial potential in browsers because people start using internet and they decided to just make a company to earn money to making the browsers. So they founded a Netscape Communication Corporation in 1993. And 1 year later, they released Netscape Navigator 1. It was a commercial product. It had some free licenses usages. But this is basically the browser was the first most used browser in 90s. And it basically was rendering just static content by that time, so just document object model. It's not the document object model we used to have now. It's something open text, something was there. But 1994, Netscape Navigator. 1995, pages were static and some dynamic was needed there. And they basically were thinking like how to make it dynamic, these pages. What they did, they invited Sun just to think maybe to bring Java to Netscape and to make it work dynamically. But Java was too big, too complex, and it was really not feasible to make it work together. So they invited Brendan Eich to invent a scripting language that will allow Netscape to be more dynamic. And they asked him, it needs to be done yesterday, right? This is how basically software development works. So Brendan Eich, 10 days, he was working 10 days, right? This is where jokes come from. He was working 10 days and he basically created some language that has syntax from Java. It also had many other cool features were inspired by some other languages, like first-class function from the Scheme program language, or dynamic typing from Lisp, or prototypes from Self. Yeah, and this language was called, who knows? Mocha. This language was called Mocha. And Mocha basically was part of the language Brendan Eich introduced. But when they decided to release Netscape 2 beta with this Mocha integrated into it, they finally renamed Mocha to LiveScript. It was LiveScript, and then Netscape 2 releases, and LiveScript was renamed to right, finally JavaScript, right? So December 1995, this is official date when we have JavaScript in place, which is great. And yeah, you know, we had around the time already Microsoft running. It was using its own operation system, Windows, and they didn't really pay attention to Netscape initially, but then Netscape migrated or implemented Netscape implementation for different operation systems, including Windows. And this was kind of dominant web browser, or the only web browser in Windows, and it was very popular. And Microsoft decided also to take a part of this cake. And they also were thinking that web browser should be free for everyone to use. And Netscape, you remember, was a commercial product. So what they did, they started working on own browser called Internet Explorer. The problem was that what they did, they basically took JavaScript from Netscape, they reverse engineered it, and they created own language with own extensions. This language was called JScript, and it's basically another branch of this scripting language for browsers. And Netscape decided, okay, something goes in the wrong direction. They went to ECMA, as MA here is not visible, ECMA International. This is kind of how it's called here. European Community Manufacturing Association is a neutral party for setting standards in technology. So they went to, it was founded in 1961, and Netscape turned to them and asked them, hey, let's standardize JavaScript because we have two languages that not the same. And in 1997, first version of ECMAScript, with code name like ECMA 262, this is also still official name, first version was introduced. The first version of this document is kind of a PDF file with 100 pages. It describes how JavaScript works, what are the functions there, what is the functionality. This was about it. 1998, Netscape was acquired by AOL. So as you know, Internet Explorer became part of Windows, and Netscape lost dominance over the Windows. And they decided to shut down the business in the way that they were sold to AOL. The good part, right before it, they open sourced Netscape Navigator, which was a really good and important move by the time. And helped Mozilla to be founded by the members of Netscape in 1994. We'll get back to this one yet, to this one soon, but I want to focus also on this one. So ECMAScript had several proposals or versions. So the first one was released in 1997. There was a second edition and the third edition. And the fourth edition was very big because it contained cool features. It was more like TypeScript nowadays. It has classes, interfaces, namespaces, and other cool things. And David Crockford, you know this guy, you might know this guy who was working at Yahoo by the time. He invented JSON. He told this is too complex, right? From transition from version 3 to version 4. And Microsoft agreed with him. So what they did, they just refused this proposal for ES4. But this one language who basically implemented ES4, ActionScript. You know ActionScript from Flash, Macromedia, Adobe? Yeah, so ActionScript basically uses ECMAScript 4. But this is off topic. Let's get back to the point. So 2014, Firefox, ex-Mozilla, they had a SpiderMonkey engine, which basically parses JavaScript. And it's not parses JavaScript, it does many other things. But parser of this engine basically making some output, which became sort of a tree. The good part about Firefox, they were really respecting standards and guides provided by ECMA specifications. So in this way, ES3 specification, output of this parser became ES3 specification, also called AST standard. And this is the time we have a standard around 2014 when we have AST specification. But you can see there are also really cool names here, important names, and some timeline dates that basically show some attempts to standardize JavaScript and IST as well. So you can just Google it later or make a photo, up to you, or I can share slides later. But important part here is JS Code Shift 2014. We'll get back to this point later, but AST. So now we know that we have standard for JavaScript abstract syntax tree called ES3 spec. What is AST itself? Who is not really familiar with it? So basically it's kind of object representation of your code after it's being parsed. Let's look at this simple example, right? This is a valid JavaScript expression. 37 plus bracket 10 divided by 2, bracket closed. This is basically abstract syntax tree for this expression. It might look like big and really verbose, but it's not really. Let's dive deeper. So as every tree, so tree I mean data structure, like in programming languages, data structure has root node, right? It has root node with type program. Every node can have some attributes, child nodes, and so on, right? So we have here body, and the first body is a list of nodes. And here we have one expression, one node basically. This is expression statement, and this is binary expression. So binary expression, it means that we have only two nodes, left and right. So you can see here the operator plus, this is it, and left expression and right expression, or node. So left node basically represents literal, type literal, and value 37. And the right node is also a binary expression with operator divide, and left node value 10 and right value 2. Hope it's clear for everyone because it's crucial to understand. So yeah, this is basically the IST of this small expression. And just a quick example, greet. This is just a function which returns this string. I will not go through all this IST again, but just some important parts here, like functional declaration with name greet, right? It has no params. It has return statement, and return statement is value hide of gem. Basically simple. So we can have JavaScript code, we can make IST out of it, and as IST is just a tree, we can mutate it. So we can update nodes, add nodes, remove nodes, so we can manipulate it like with normal data structure. And if we compile it back to source code, we have modified code. So code shifts, just code shift in action. Let's go quickly here. So as I mentioned, this is, I think, the most popular tool for building code mods, or some code mods basically built on top of JS Code Shift. Before we going deeper, let me give you one more example from real use case from one of the projects I was working on. It's a comparatively big project with many product teams, and to support product teams, we had the front-end platform. So to make the code work properly, we had many repositories. It was more than 100 repositories, and every repository was owned by some domain. We have many services running in production. We have daily releases, quite regular. And as a platform team, we own some core repositories. And let's say we have some, sorry, maybe I go back here. So some of the repositories in artifact of basically repository was npm artifact on npm package. So it was not a monorepo, it was just different repositories, and you can think of it like just a package released from one repository was used in other repositories. So let's say we have a small example. We have Acme design system package, and we, for instance, update button in this package. So it basically leads to many changes in many places and many consumers of this library. It's really tricky, and it was working well. And we had a lot of automation in place to update dependencies, to orchestrate them, and so on. But what happens if we have some breaking changes in some of the libraries? Let's look deeper into this example. So we have design system version 1, which exposes primary button component. It's React code. I hope you're familiar with it. It's as simple as possible. It has one parameter on close, or should be on click here. Maybe I need to change it later. It's a typo. And we have another component, payment success. And basically, this component consumes this primary button from design system 1 in this way. Primary button on click, on close. We have a breaking change in version 2 for design system. instead of primary button, we now rename it to button and to generic button and provide here a kind. So kind can be like primary now or other kind. So this button expands on functionality. So payment success basically should be refactored or change it in this way. So we change import from this design system package from primary button to button. You add here one more attribute kind with value primary, and it will work as needed. This is basically a Git diff, how it looks like. So far it's straightforward, it's clear? All right, cool, let's move on. So it's easy to apply this change. We can do it, we can look on the first slide, we have a developer, he can do this work, right? If we do this work n times, we can have n developers or ask the developer to do it n times. If you have 100 projects multiplied by 100 projects, how should we deal? Automation. I think automation is key to success. So what we do, we need to have some code base. Code base can be namespace, can be a local machine, can be some remote code. We need to modify code in automated pipeline. We need to apply auto fixes because, for instance, some linting things or some redundant statements that are not needed. We run tests to verify that everything works fine. We build code to verify everything works well, and we commit changes. So this is basically automated pipeline. Now let's focus on this automated modification of this code. JS Code Shift. So now let's look at how we can automate it with JS Code Shift. This is a tool which basically has quite straightforward API. So this is a command, and you can provide some parameters here. So just call JS Code Shift. You provide here transformer. This is a function which basically transforms your source code. And we provide a source you want to apply this transformation for. This is transform function. This is how it looks like. Scary?
Yes.
Right. But it should not. Let's break it down. It's really simple. So API is quite straightforward. We just export some function which accepts several parameters. So file info is just details. It's not even needed. So API, this is API. File info needed. Yeah. API is API of JS Code Shift, and some options we can provide here. So parameterize, for instance, this code mod. So this is a crucial slide for understanding. So you can see this AST line when I'm highlighting. What we do here, we just parsing our source to abstract syntax tree. So this now is abstract syntax tree. In the end of this function block, we basically return AST to source. So we compile back AST to source code. And what's happening in between is just basically mutation or modification of the tree. Let's look at our example. So we have this import in the payment success component. We have import of primary button. So you remember in IST, this was looking like we have import declaration with source value Acme design system, import specifier primary button. This is how this statement look in the IST. So what we need to do, you basically need to traverse this tree in IST and find this import declaration with source Acme design system. Then we looking for all import specifiers. So import specifiers here is basically card, primary button, text. And then we just looking for import specifier which is primary button. So we're targeting this specific node. And then we replace this node with something new. So with something new is just creating new node. We're creating new node in IST using this API from JS Code Shift. We create import specifier, identifier button. So with running this one, we just replace primary button with button. So far clear? Okay, cool. Let's make it a bit more complex now. So we have another statement was part of our component. We have rendering of primary button with on-click close in primary button here. How we can fix this one? It's also quite straightforward. Let's look for all JSX elements within this IST. Let's look for the opening for a node which has opening element with name primary button. And for each of this element, It means for each, because we can have multiple primary buttons in the component, and we traverse for all of them. What we do, we create a new element. So once again, for each of these element, primary button, we're creating new element. So new element is just empty node. We're saying, okay, create opening element with button identifier. So add to this opening element this X attribute kind with string literal primary. This is what we have after this line. And then let's copy all other properties from our original node. In this case, we can copy onClick and everything else we had in the original node. Then let's add the closing element here. This is a button closing element. And just copy all the children here. And next, replace the original element with this new element. So yeah, take account that this is a mutation of AST. So we're not using functional programming here, like return new instance of AST. This is a mutation. Therefore, we just do this one thing, like replacing one node with another node. If we need to apply this change for every file in our code base, we just need to run this transform in our code base. And it will automatically update all buttons, or all primary buttons to new buttons. With automation at Konbot and Codemods, we can integrate it in pipeline and make part of our routine of upgrading packages and making our breaking changes. So yeah, we can update even more. So if you integrate pipeline for updating this package, we can also update it in every repository automatically. What's next? This is a very cool resource called AST Explorer. It allows you to add here your code, to choose parser, to enable transformer. You can see here this JS Code Shift transformer, to try any here transformation function, and you can see here outcome. Usually it should be here abstract syntax tree, but somehow it's not visible. Here you can also see abstract syntax tree. Awesome Codemods. So a list of Codemods. Of course, it's open source. You can find a lot of cool stuff there. You don't need to write everything from scratch. You can learn from it. JS Code Shift community. It's also a community created by some authors of JS Code Shift. They also provide here some tools. They also have some public registry for Codemods. They can even use CSS Codemods, which is also something cool. Put out. I think I was really inspired with put out. This is kind of a declarative way of writing Codemod. It's not like imperative way, we just finding this node and finding this node. It's really awesome project, and I think it's underestimated. So we also use put out at this project I was referring to. So please check it out. It's really simple. It's really powerful. I don't know why it's not used everywhere. It doesn't use JS Code Shift under the hood, but it was inspired by JS Code Shift. And you can see it supports many languages and many syntaxes. And yeah, AI code generation. I asking, hey, ChatGPT, could you create a code mod for our div? Right? I did it in the train this morning, and it just gave me this JS Code Shift transformation. It's another way. Thank you.